Outside the planet's orbits in the solar system, there is a cold region with very weak sunlight. There are countless small frozen objects there. Some form a dense, hollow, disc-shaped belt, and some form a spherical cloud wrapping the solar system. These small bodies are leftovers from the solar system's early formation, remnants that were left behind. They keep records about the solar system's origin and important clues about how it evolved. In this episode, let's go on a magical journey deep into the Kuiper Belt to visit these frozen worlds. Then cross the Oort Cloud and head for the edge of the solar system. Beyond Neptune lies the Kuiper Belt. The Kuiper Belt's most iconic objects are Pluto and its rocky companion, Charon. Pluto is about 30 astronomical units from the Sun at perihelion and 49 astronomical units at aphelion. Its orbit is highly elliptical, with a period of 248 Earth years. That means Pluto is sometimes closer to the Sun than Neptune, but most of the time, it stays in a distant, frozen world. Pluto was once even called the 9th planet of the solar system because older observing technology was limited and its size and mass were estimated wrong, so people thought it was much larger than it really is. But later, as observations improved, scientists found Pluto's diameter is only 2,370 kilometers, just about 18% of Earth's. So, because it is small and sits in the Kuiper Belt, in 2006 the International Astronomical Union reclassified it as a dwarf planet, alongside bodies like Eris and candidates like Sedna, seen from Earth. Pluto is only a dim brown dot. Even the Hubble Space Telescope can barely make out surface details. To lift the veil, in 2006, NASA launched the New Horizons probe to visit this mysterious world up close. After a long journey of 9.5 years, on July 14, 2015, New Horizons flew past Pluto and carried out about 400 observations, collecting a huge amount of data. New Horizons revealed to us Pluto's varied landscapes. It has vast plains of nitrogen ice. The largest is called Sputnik Planitia. It also has towering ice mountains, such as the Hillary Mountains, rising up to 3,500 meters, and even deep canyons. Pluto's surface also has a thin atmosphere, mainly made of nitrogen, methane, and carbon monoxide. Near perihelion, these ices can sublimate into a thin atmosphere, and when Pluto moves farther from the Sun, they freeze back into solid form. Because Pluto is so far away, its surface temperature can drop to about -230 degrees Celsius. Near Pluto, the largest nearby body is Charon. Together, they form a unique double-body system because they orbit a common center of mass. They complete one mutual orbit every 6.4 days. This makes Pluto and Charon always show the same side to each other. Charon's surface is covered with canyons and impact craters, and its north pole looks reddish. This red color may come from methane that moved over from Pluto's atmosphere and settled there. After leaving Pluto and traveling deeper into the Kuiper Belt, we find other dwarf planets here, such as Haumea. Haumea was announced in 2005 by a team led by astronomer Mike Brown. Its distance from the Sun at perihelion is about 35 astronomical units, and at aphelion it reaches 50 astronomical units. That means sunlight reaching Haumea takes about 5 to 7 hours. Its orbital period is 284 Earth years, and its rotation period is about 3.9 hours, making it one of the fastest spinning dwarf planets in the solar system. Because it spins so fast, it is stretched into an oval shape. As we go deeper into the Kuiper Belt, we come to Makemake. Makemake is the third largest dwarf planet, with an average diameter of about 1,430 kilometers, about 3/4 the size of Pluto. Its perihelion distance is about 38.5 astronomical units from the Sun, and its aphelion is 53 astronomical units. Its orbital period is about 309 Earth years. Makemake's surface temperature is also extremely low, down to about -243 degrees Celsius, and it is covered with thick methane ice, ethane ice, and a small amount of complex organic material. Under sunlight, these materials look reddish. After we leave Makemake and continue deeper into the Kuiper Belt, we find several more distant worlds, such as Gonggong, Quawar, Eris, and Sedna. Among them, Sedna is one of the most remote known objects, often considered a dwarf planet candidate. Its orbit is extremely elongated, and its distance from the Sun at perihelion is about 76 astronomical units, while at aphelion it reaches 937 astronomical units, almost stretching across the whole outer region. This means its orbital period is about 11,400 Earth years. That is why Sedna is one of the farthest known objects in the solar system. Its surface temperature is also frighteningly low, around -261 degrees Celsius. Leaving Sedna and moving on, we will leave the Kuiper Belt and enter the region of the Oort Cloud. The Oort Cloud is like a huge spherical shell surrounding the solar system. It is the home of comets and a living fossil from the solar system's earliest days. The Oort Cloud is named after the Dutch astronomer Jan Oort. In 1950, he proposed that long-period comets may come from a distant spherical cloud orbiting around the solar system. This idea helped explain the mystery of where comets come from. The Oort Cloud is a hypothetical spherical region in the outermost part of the solar system. Its objects are mainly made of water ice, ammonia ice, methane ice, and some rock. They range from a few meters to a few kilometers across. Its total mass is uncertain, often estimated at a few Earth masses. The formation of the Oort Cloud is closely tied to the birth of the solar system. About 4.6 billion years ago, the Sun collapsed from a huge molecular cloud, forming a disk of gas and dust around it, a circular protoplanetary disk in which the high heat in the inner solar system made dust clump into rocky planets. Farther out in the outer solar system, low temperatures let icy material gather into giant planets, but many icy fragments never became part of any planet. Pulled by the strong gravity of the giant planets, they were flung into much farther orbits. These fragments are thought to make up the Oort Cloud. Because the Oort Cloud is so far from Earth, it has never been directly observed. That's because it is at the Oort Cloud may begin around 5,000 astronomical units from the Sun. In other words, it wraps around the entire solar system, possibly stretching tens of thousands to about 100,000 astronomical units from the Sun. At such a huge distance, at the outer edge, sunlight could take many months to over a year to arrive. Even if we use humanity's farthest traveling spacecraft, Voyager 1, it would still take tens of thousands of years to reach the edge of the Oort Cloud. The Oort Cloud reminds us just how vast the solar system is. With today's technology, for humans to leave the solar system is basically a fantasy. Unless in the future, we invent propulsion that no longer relies on chemical rockets and can keep accelerating to a few percent of the speed of light. Only then might we reach the edge of the Oort Cloud within a few decades. If one day in the future we truly manage to leave the Oort Cloud, we will discover that this is only the first step, just the tip of the iceberg of the Milky Way. Because the Milky Way is about 100,000 light years across, and it contains countless stars. The closest star to Earth is Proxima Centauri, but even it is 4.22 light years away, and the farthest ones are hundreds of thousands of light years away. It's hard to imagine. Humans are so tiny in the Milky Way, and even more astonishing, in the observable universe, the Milky Way itself is only a small galaxy.